So yeah, earlier today I kind of talked about this complicated way I let people into my apartment. Right now I'm going to talk about kind of hashtag day job. So we are both engineers at a company called Datalot. We run a call marketplace and a call center. I'll kind of explain what both of those things are. But thanks for joining us. So quick outline, we're going to talk about kind of who we are, what we do at Datalot, dive specifically into how we use Twilio, and then kind of outline some of the lessons we've learned. Another way you could put that is some of the mistakes that we've made, so you can kind of learn from our mistakes. We use Twilio a lot at high volume and have been for a while. So obviously we've made some mistakes along the way. Just to get a sense of what we do, this is our homepage. We basically run a call marketplace. What that means is we sell live call transfers. I'll just explain a little bit more about that model and what that means in a second. But first, let me just tell you about a little bit about Datalot. We are in the online advertising and lead generation space. My mic okay? Yeah, still hear me? Our company has a technology-first philosophy. So while we're in the advertising and marketing world, our data and kind of bleeding-edge technology kind of lead the way in terms of like what we do by day. Have about 60 employees. About a third of that's engineering. In addition to that, we have a call center with about 100 reps. Some of those guys are in our remote. Some of them are in the call center. Some are full-time. Some are part-time. Our HQ is in Brooklyn. Our main contact center is in South Florida. Founded in 2009, which is when we made our first test Twilio call, so we've been using Twilio for a while. I joined in 2011, Elliot joined in 2013, and we help build software that runs the world's most advanced call marketplace. So let me explain what a call marketplace is. But to just back up for a second, so 2009 when Datalot was founded, this is what phones looked like. This is what the front page of Facebook looked like. They had just gone through a redesign. And iPods were all weird and colorful. So some things haven't changed since 2009. There are still like certain products that people will only purchase over the phone. So think about things like you're not going to add a life insurance policy to an online shopping cart and hit checkout. You're going to want to talk to a human being on the phone. How people get on the phone has changed. Mobile search is huge now. So instead of kind of dealing with the yellow pages, someone might do mobile search and there are just buttons to click to make phone calls. Okay, so what is a call marketplace? We sell live calls. What that means, the easiest way to think about that is think AdWords, but for phone calls. So instead of advertisers bidding on clicks, they're bidding on live calls. They bid. Instead of getting click traffic, their phone rings. They pick up, and they close the deal or whatever. So here's just a quick example of how this works. We have are these showing up or no? Yeah. Okay. So here's our consumer. Like I said, we deal mostly with kind of the sorts of products that you're gonna want to talk to a human being on the phone. So our bread and butter is insurance, life insurance, health insurance, auto insurance, but also kind of we deal with home services and a bunch of other verticals. Things where, like one other way to think about the products we deal with are places where the yellow pages are going to be very fragmented. There's no like one market leader in that, and kind of there's just lots of people selling that product over the phone. So for this example, our consumer is searching for some kind of special lemonade that they can only buy over the phone, some artesian lemonade. And here are our lemonade vendors. So when we first started, we mostly used an IVR, so that consumer somehow connects to our IVR either with an inbound or outbound call. And we're going to kind of qualify their intent. We might collect some additional information. And later on, we introduced a call center where our reps could do the same thing and add more value to that consumer's call. And eventually, basically, we're going to transfer to the best client. And by best client, I mean a client who might maybe only serve, maybe this consumer is only looking for a sugar-free lemonade vendor in the state of North Carolina. So our clients have filters and they can buy certain types of calls, just like with AdWords, you can only buy certain kinds of traffic, you can kind of target that stuff. But also our clients are bidding on traffic, so this client might be willing to pay more for a call, and therefore they're more likely to get that call. So now Elliot's going to dive into a little bit more detail about these kind of key players, the consumer, the clients, and the call center and IVR.
So how does the consumer actually end up on the line? Well, either they're calling us or we're calling them. So when they're calling us, this is an inbound call for us. So maybe they found a phone number on one of our websites that they're calling. Maybe they hit a click-to-call ad while they were browsing on their mobile phone. Maybe it's a qualified inbound transfer from one of our partners who also has a call center. Maybe that partner uses SIP, so they're passing in additional product and contact info about that consumer when they're being transferred to us. Or we're dialing the consumer. Maybe they filled out a form on a website, or one of our partners posted to our API that consumer's contact info and the products that they're interested in. Maybe we already talked to that consumer and we're just calling them back after rescheduling. Or the consumer texted us, hi, I'm interested in auto insurance, and we're calling them back with that information. So here's an example of someone whose cat is stuck in a tree, so they've quickly Google searched kitty rescue. And they see there that the first website is one of ours, herolocator.com, and they can either hit call, which would be a click-to-call ad, which would dial us, or they can go to the website, need a superhero, and they fill out, okay, here's my name, here's my zip code, here's my phone number. And when we click go get them, we would actually queue up a call to dial them, or they could call us from the inbound number again. So they've clicked go get them. We've provisioned this phone number that's in the same area code if we don't already own a number in that area code for this particular product. Here's an example of what one of our API posts looks like. It basically, I know it looks like a lot, but it basically boils down to the consumer's phone number and, again, their product info. So what happens when the consumer is actually on the line with us? Well, back in 2009 when we first started, they were hitting an IVR that just asked the question, are you interested? Press 1 if you're interested. But today we collect a lot more data, like the consumer's date of birth, their zip code, product information, or maybe just a better time to call that consumer back. But in 2011, we started experimenting with using humans on the phone instead of an IVR. And at first, they did the same thing, asked, are you interested? And that caused a 50% in conversions, which is huge. They're doing the same thing as the IVR, but it was way better transfer rate. And it's basically the easiest job in the world, but by now, we do a lot more with that. So we disposition calls, we collect better information, we address the consumer's concerns. We do a warm handoff to the clients, which is basically introducing the consumer and client over the phone. And we can skip bad clients if maybe one of them has an answering machine. The agent knows to go on and try another one of our customers. And as well, obviously, better rescheduling. People can figure out a better time to call someone back than an IVR can. This is what our agents see when they're talking to a consumer over the line. This is the agent dash. In this case, we're talking to Johnny Sunshine, whose cat was stuck in a tree. And we figured out that we need super strength in the lower right to rescue this cat. So when we hit transfer, we're going to transfer to a client that has that attribute. So to go over our clients a bit more, they're our customers, and they're the ones who are bidding on calls in real time. And we pre-qualify those calls, do that warm transfer where we're introducing the consumer to the client, and then the clients close the deal. So here's a chart of what that customer acquisition funnel looks like. So the old way is people would spend advertising dollars on casting a wide net and having consumers gain awareness of their product. And then the rest of dealing with consumers' considerations, and maybe they don't even want to buy the product at all, and then finally collecting their credit card information was all on their sales team. And what Datalot tries to do is take care of all of that so that our clients just have to close the deal. Here's what the dashboard looks like for our clients, so they can pause calls on and off. They can select how many calls they want with their concurrency cap, calls at once, and they can specify what number we're supposed to transfer them to. The targeting on the right side for this client, they only want calls in Florida and Georgia, and the particular product that they're interested in is auto insurance. And then of course, the schedule in which they want to receive calls, and in this case, this client would receive 50 calls between the hours of 8 a.m. and 3 p.m. on Monday. And also some numbers. So our first Twilio call was in March of 2009. And in 2014, we had 10 million calls to consumers. So that's not Twilio dials, that's actual talking to contacts. It doesn't include transferring to clients. And 87% of those were mobile calls, which is a huge switch from mostly connecting with landlines. And we have 100 reps on per day. With, and as well, we have owned 35,000 numbers in our ring pool, which is how we create unique caller IDs for all of our websites and products. So I'm going to pass it back to Adam to go over how we use Twilio specifically.
Cool, thanks. So I'm just going to kind of step through how specifically we use Twilio. So our IVRs are going to use kind of a lot of this TWIML, gather, say, play to kind of collect consumer information. For outbound dialing, we're using the phone number provisioning API. When we dial, if we don't have a number that both tracks back to the consumer's location and the campaign we're dealing with, because we want to track back both things. We're also going to, dial over REST. And if a consumer doesn't pick up, we might send them a text and say, hey, sorry we missed you, give us a call. We were calling about the auto insurance quotes you requested or whatever, something like that. So we'll use the SMS APIs. Inbound numbers, we have this ring pool. We have the ability to dynamically provision APIs. We can give sources of ours a JavaScript tag that'll kind of throw a dynamically provisioned number on their site, but we also might manually provision numbers for, like, say, a Google ad that's using certain keywords and we want to track how the ad's performing. So we might also use the phone number API there. For inbound call routing, we'll use the queue verb to hold that inbound call in a queue for a second or two while we figure out what rep is the best fit for this consumer or whether it should go to the IVR. Our call center all runs in the browser, so all our reps just have Chrome boxes. We're using Twilio client. We're using some other non-Twilio things to push the scripts to the screen. Queue and conference to connect the reps and consumers. Call center managers have the ability to listen into calls in real time through the browser. So they're basically joining, they have a button and they just hit join this conference on mute and they're just listening into their reps' conversations in real times. Client transfers will outbound dial, maybe to a phone number, maybe to a SIP endpoint, and we'll use conference to do that warm transfer where first our rep will talk to the client, let them know who the consumer is we're bridging in, then we'll bridge all three parties in together, and then finally our rep will drop out and it's just the consumer and the client talking to each other. And our clients have a similar web interface where maybe their call center managers want to screen calls and listen to them in real time. And then a couple other fun uses for SMS, MMS. We'll notice that sometimes when we miss calls, someone will just call back and not recognize the number. They'll say, who's this? So we have the ability to text back and we have someone managing a SMS chat interface to kind of talk to folks. And one of the campaigns we run is for junk car products. People are selling cars that they're getting rid of and our clients are buying those cars. So we have the ability for our consumers to text us a picture of their cars, and our reps can kind of then figure out the value of those cars and who are the best clients to buy those calls. So let's dive into some specific lessons learned while building out both this marketplace and our call center. So lesson one is basically respect Twilio's authority with regard to call state. When we first started, we tried to keep track of call state and also assume we were the authority, and things happen like a nanosecond after you log something, or you might have database log. So there are mechanisms built into Twilio to ensure that to basically trust Twilio's knowledge about the state of a call. So here's an example. This top example, we're basically making a REST request to redirect a call. And every time we make that request, Twilio is going to go, okay, and just blindly redirect the call. So if we have two processes very quickly trying to send a consumer to rep A and rep B, Twilio is just going to send it to rep A, and then if we don't know that it correctly sent to rep A, we'll try again and just send it to rep B. So this bottom example, if that consumer is in a queue, the first time we make that request, Twilio is going to return a 200, say, cool, that was successful. And if we got it wrong and we didn't know call state and we try again, Twilio is going to return a 400 and say, actually, you already sent that call somewhere else. So use those mechanisms that are built into Twilio to kind of deal with call state. Lesson number 2 is don't block call flow. So here's up top some kind of pseudocode what might happen when we connect to a rep. So we might run this function, find a rep. Then we might want to write like revenue to our revenue table. Then maybe we have a function that sends like 50 emails. Then we might want to hit the pusher API or some WebSocket API to make that script appear on our rep screen. So what if our revenue table is blocked? Or what if it takes a long time to send 50 emails? Or what if there's some weirdness with pusher? So things that aren't critical, that don't need to happen before you return that XML, you can move to the background. So now we have, in the bottom example, we have a background worker consuming kind of those connect events and doing all those, doing the writing of the revenue and the emails and all that stuff in the background. Another way you could do that without dealing with background workers is if you're handling requests in Node, things can happen asynchronously because this is JavaScript. So all of those things, the writing the revenue, the sending emails, we're not going to wait for that async block to finish before we return that XML to the HTTP request. Lesson number 3, pick your data stores wisely. So we don't follow like a dogmatic view of like relational is better or NoSQL is better. Form follows function at Datalot. We're very practical. We'll kind of use the best data stores for the that kind of suit the function. MySQL at Datalot kind of serves as the authoritative call record. We have a master-slave setup. Master when it's like super, super critical that we know exactly like the state of the call. Slave when it's a little bit less critical. MySQL's battlefield tested. Lots of folks use it. Our business people speak this language, which is very important when the culture of your entire company deals a lot with data and split testing and analytics. So our business folks are pretty well versed in MySQL. We want them to kind of run queries and know what's going on, get under the hood. And also this is like a nice easy way to push features before like design and front end folks get to building a UI. We can just have a flag in the database and business folks or whoever can just use some MySQL client, log in and change that. We'll use Redis for in-flight and transient data. And this stuff, if it's important, eventually gets written to MySQL. Redis is nice in that it's single-threaded. We don't have to worry about processes stepping on each other's toes. We know that like our requests are going to happen in a specific order. Keys expire, which is nice not only for keeping the size of Redis nice and small, but also allows you to build little locking mechanisms, things like that. And we use Redis a lot for set comparison. So one way to think of that is kind of Venn diagram type stuff. If we have like a big circle of all our queued calls, and then like a subsection of that that's auto insurance, and like a smaller subsection of that that's people looking for auto insurance with no DUIs within the state of Florida, but that we haven't called already. So we can do all these set comparison functions in Redis quick and kind of pull out the call IDs that are either intersections of sets or combinations of sets or diff on those sets. So one thing I'll just kind of mention here. So Elliot's going to show a slide in a little bit about kind of UIs we've had to build because there is no MySQL. There's MySQL clients with Redis and the set comparison stuff. We've had to build some internal tools for ourselves to kind of run set comparison queries when we want to visualize them. We'll use Redshift for analytics. It's just really great for handling large amounts of data very quickly. And now I guess back to Elliot for some more lessons learned.
Right, so another lesson learned that we have is beware of WebSocket bloat. So as we continue to get more features, feature requests about what should go in our agent dash, and as we had more dashboards that were showing us what was going on with live calls as they were coming in, one of our main events started to look like this. It's a massive JSON blob that is just a huge payload and tying up the network in our call center, and was also being sent on one channel. So whenever one agent got a call, we would send this to all of the agents, and then the client-side logic would have to look at what the agent ID is here and figure out if that's even relevant to them. So we split up all of the agents into having their own WebSocket events, and as well reduce the complexity of the data that we send to the agent dash. So it's just bare bones, what is the contact info and call ID, and the dash figures out how to display that. And as well the client admin that I showed you earlier, we just send the call ID and the conference name so that the client can start listening into that phone call as they receive calls. Lesson number 5 is get inside the browser. So obviously a lot of our application is a back-end one, but we also have this very complicated front-end application as well. And we don't always know what's happening when one of our agents tells us that something went wrong with one of the phone calls that they had. So what we did was we created a bug report button. So you can type in, hi, the consumer sounds like a duck, I hear quacking, hit send, and now we can see everything that happened within that dash before something went wrong. We can see screenshots, we can see the user agent, and as well we can see all of the console logs associated with that agent session. By the way, that library that we use to generate the screenshots is HTML to Canvas, if anyone wants to use that. Another useful way we found to get inside the browser is to open up Chrome via remote debugging. So with that, you can look at the developer tools on another computer. So if we have someone in the office taking calls, we can inspect what's going on inside their browser without kind of hovering over their shoulder. Lesson number 6 is make the invisible visible. Here's a tool that we developed to help debug our script templates. So if we want, we can look at, well, what did the script look like for a particular call? And we can see the script templating language as well as how that script was rendered. This is the slide that Adam mentioned where we're trying to do some inspection on our agent filter Redis sets. So on the left-hand side, you can see examples of different filter set attributes that we would want to select how an agent would want to take calls. Like maybe they're only good at a certain product or only good at taking inbounds versus outbounds. And that JSON in the center there is how we can construct the unions and differences between the different agent filter sets. And we'll spit out a list of phone calls that would be associated with that set. We have a process called DialBrain that basically has to do a lot of things really, really fast, like milliseconds fast. So we have this dashboard that will start to light up red if something is going wrong within our infrastructure somewhere. So this is something that we have on the wall in our office, and usually when we hear a bunch of bug reports going on, this is also turning red. This is basically the same thing, but within our console, and is only one of those processes. And here's a macro view of what's going on in our call center. A lot of these are describing the different call states for different groups of our agents. And in the top, we're also looking at, are we receiving Twilio errors? Are we receiving internal bug reports? What is the Twilio heartbeat, which Adam will go over in a little bit. And as well, if you zoom in, you can actually look at what the individual bug reports are. So here's Adam's bug report from earlier with the consumer sounding like a duck and hearing quacking. Lesson number 7 is know what time it is. And really, there's a lot of difficult time zone issues that you have to overcome while building a call center. And you need to deal with that for legal reasons. If you're calling a consumer at 7 in the morning, not only is that going to piss them off, but you could get sued, which is bad. So for clients, this is really easy. If you look in the left-hand side, you see that their schedule is in EST in this example. So we know what time zone the client wants to receive calls in. They can just specify that for us. But for the consumer, if they haven't filled out where they live online, we have to kind of guess based on their area code. And what we do with that is figure out what their time zone offset is. And right before we dial, we run a MySQL query that looks like this. At the bottom, you can see we're comparing now, which to us is East Coast time, to the consumer's time zone offset. Here's the terrible pun. But wait, Arizona, Hawaii, have you forsaken me? These guys don't honor daylight savings time, so you can see we added a bit of extra math to kind of deal with that. So here's what the agent dash looks like when we're wrapping up a call with a consumer. Call is ended, and we want to reschedule that consumer for a specific time, and they've said, call me back at 6:15. Well, that's the consumer's time, not our time or maybe the agent's time if they're not on the East Coast. So we say, okay, we'll call you back at 6:15, but we know that that's 3:15 our time, so that's how we're going to save that for us. So I'm pass it back to Adam for more lessons.
Okay, so am I back on? Test. Okay, so lesson number 8, slice and dice your data. I think this is kind of gets to the heart of kind of how we some of the business philosophy at Datalot is kind of we'll always split test and kind of look at our data and try to figure out how to kind of squeeze more value out of calls for our clients. So first early example of this is when we started building our call center, we just had a little call center lab in the corner of our office. We had a couple of part-time guys, and we were just trying to prove out, is it worth building a call center? Are we going to get more value from transfers when people talk to humans? That ended up being a big win. There was a huge lift. When we first started, we kind of just had a hodgepodge of numbers that we would call from, and we wanted to see if we would get more answers if we called from local numbers. And again, there was a huge win there. We got a huge lift from kind of provisioning all of those local caller IDs that track back to campaign and location. IVR voices, we said, is there going to be a lift using male voices over female voices or friendly voices over stern voices? That's kind of like a medium win. There's nothing definitive there, but kind of when we build our IVRs and get scripting done, the language definitely matters, and we definitely have the ability to split test IVRs to kind of optimize conversions. Hold music, I thought this was going to be a huge one. I thought we were going to write a psychology paper about upbeat music does this and downbeat music does this, and this was one of Elliot's first projects when he joined, and it was a big waste of time, but it was fun. We had an office pool, everyone picked an MP3, didn't matter. Voicemail detection, so Twilio has AMD detection. They detect answering machines. The way it works is there's a second of silence inserted at the beginning of a call. And if there's audio during that second, Twilio tells us it's a voicemail. So the problem is we were worried that 1 second was going to turn off a lot of consumers because they pick up and they go, hello, hello. And it turned out that was right. It wasn't worth our time building, it wasn't worth it to use Twilio's AMD detection. But then we looked at the data ourselves and kind of, we have agents dispositioning every call. We know kind of data, in terms of data, what a voicemail looks like. And we noticed that, AMD algorithms were built before cell phones and before you get a voicemail right away if the battery's off or the phone's out of service. And we noticed that 99% of the time, if someone answers in under 4 seconds, it's a voicemail. So we just wrote our own voicemail detection algorithm, which is literally, did someone answer in under 4 seconds? If yes, it's a voicemail. Don't waste agents' times with these calls. And there was no 1 second inserted at the beginning of the call. Next quick lesson, take your pulse. What we're doing here, we call it Twilio Heartbeat. We're calling one of our own numbers. We want one analytic to look at. We call one of our own numbers with Twilio. We return a busy signal. We log how long it takes to detect that busy signal. So we're just calling ourselves over and over, returning busy. That should take less than a second. And when that heartbeat looks bad, when it takes more than a second, we know that there's something wrong between us and Twilio. We don't necessarily know what it is, but we know there's a problem. Second, the black line is when heartbeat was rising for some reason. Those bars under it are Twilio errors. We spotted the error before we got Twilio errors. That top line is agent fails. That heartbeat number doesn't get to exactly what the problem is, but it tells us there's a problem quickly and gives us one number to kind of throttle back dialing or turn dialing off programmatically. Lesson 10, real quick, QA. This is our QA guy. He's a guy in our office who knows how to take calls, but also knows how to look at the console. Our reps, when they submit tickets, those also get posted to our chat room, and our QA guy kind of works as a traffic cop to let the right account managers know there's problems if it's a client-related problem. Another QA thing real quick, we built this game called Rep Invaders. It plays 10 seconds of audio. You have to click and guess who's the rep talking and whether they made a transfer or not. It's just a great way for people to kind of hear the pulse of the call center. We have development environments for every account I've kind of gone over. So here are our lessons learned. Respect Twilio's authority with regard to call state. Don't block call flow. Pick your data stores kind of based on function. Watch out for WebSocket bloat. Get inside the browser. Make the invisible visible. I'm over. So here. Thank you. Let us know if you have questions, and also we're hiring if you want to help us solve these problems.